In this problem, we are trying to figure out the transformed graph that results from starting with f of x, which is graphed in blue here, and 3 anchor points identified as well. So let me start by labeling those anchor points. Looks like we have 3, 2 for this one on the right. The vertex at 1, -2. Got to be careful with that vertical scale. It's going by 2's instead of 1's like the x scale. And then the far left anchor point that's noted is -1, 2. All right, so they give us the function here, and then they give us the version of g, and then they ask us for the graph of it. So the key is going to be to identify what is the changes that have actually happened. Have we noticed some inside layer changes inside the inputs? Do we notice some global changes, like to the whole entire thing? Are there sign changes on any of the terms? Is that what's going on? Or do we just have constants added or subtracted to the end of it for shifting, vertically shifting? So, lots to consider, but where your thinking cap kind of gets a little tighter is when we just straight up compare it. So I don't see any parentheses popping up down here in g of x, so the inner layer is not necessarily being messed with. What I notice is that everything's twice as big. So when you compare the original terms here, x squared minus 2x minus 1, to the individual terms in g of x, they're all double the size. So think of g of x as twice f of x. Okay, so if I put x squared minus 2x minus 1, that original f of x function, and factor a 2 out of that, I could see that what I'm dealing with here is an outside layer multiplication by 2 on the original function. So in that regard, we could label this and think of it as a vertical stretch by 2. When that scale factor is larger than 1, that's when we get a stretch, vertically speaking. Okay, so what I'm going to do is just go back to the original graph and double all the outputs. So every y value on those anchor points, I'm just going to double it. So that'll give me a new point. I'll have to find it 3, 4, 1, -4, and -1, 4. Just doubled all the y values. Okay, and you could think of it like this. You could say, okay, the x, y of f, this is f's points, when you go to the values for g that you're going to see, the only difference is the y's are doubled. Okay, all right, and the one that matches that would be C. We're going to go with C because you could see 3, 4, just like we said, 1, -4, and -1, +4. All right, I hope that helped.